right, it's time for more calculus. Yay! Woo! Okay, did you get enough cheering out? Let's just do this. Okay, given below is the graph of the function f of x. So the first thing that you want to do in every one of these graphs is make sure that they are labeled. This one is labeled, but make sure that you really know this is f of x. You're going to be very angry at me, at yourself, at, I don't know, the world, if you go through one of these and you're thinking about this as f prime or f double prime when really it's f of x or one of the other ones. So state all of the conclusions that you can state about the graphs of f prime and f double prime. Okay, so let's do this thing. So if this is f of x, and I want to state some conclusions about f prime, remember that this is the slope, or the slope of the tangent of f of x. So if this is my graph of f of x, and I can see right now that I'm increasing and then decreasing and then increasing and then decreasing, I'm going to use that because I know if f of x is increasing, f prime is positive. So, I'm going to say as, and you can say this, like you can say the statement first and the conclusion afterwards or whatever, the justification first, the conclusion afterward, I don't care. I'm going to say as f of x is increasing on the intervals, and I'm just thinking, where is f of x increasing? So I can see from negative infinity, negative 4, negative 2 to 1, and that's it actually. So I'm going to just say and negative 2 to 1, and you don't want to use unions or anything in here because that would mean it was ever increasing, and this is not. Like, it's kind of here. I can see these values are below these ones. So f of x is increasing on the intervals negative infinity, negative 4, and negative 2 to 1. That was from here to here. F prime of x is greater than 0. That's my conclusion. Yeah, f prime, you could have said f prime is positive. Likewise, as f prime of x, or I should say as f of x is decreasing on the interval, or intervals, and I can see it's happening from my x value to my x value, so negative 4 to negative 2, and 1 to infinity, so my x value to my x value, 1 to infinity. Then I'm going to say f prime of x is less than 0. I can also find some things. I can say f has relative extrema, or I could say local extrema. Extrema meaning mins or maxes. You could say extremes, but extrema sounds super fancy. F has relative extrema at x equals negative 4, x equals negative 2, and x equals 1. So here, here, and here. And I can see there's nice, like, smooth curves. So I don't even just have to say that f prime could be 0 or does not exist, because these are nice, smooth curves. Therefore, f prime equals 0. And I might even say as f is smooth, or has smooth curves. Has smooth curves. That says has. You can tell because I said it. Okay, so all sorts of things. So this was graph of f of x. I can tell all sorts of things about f prime. And remember that f prime would all be about like the slope, so positive or negative. And I can say something about the relative extrema too, for f of x being equal to 0 for f prime. F double prime, this is the slope of f prime, but you should be thinking about concavity. So if you have a graph of f of x, what's that saying about concavity? So this isn't actually telling you these places of concavity, but I'm going to just like pick them, and I'm going to say, you know what, it looks like it's about changing maybe like here and here. If you had an assessment of any sort, I would definitely be more clear. But I'm going to say at, I don't know, like negative 3.2, maybe? Is that where it is? And over here at negative like 0.9, that looks to me where f of x is changing concavity or has a point of inflection. I can see it's going from what looks like a frown, concave down, to a smile. And here's where you can't really tell whether you're sad or happy. That's the point of inflection. So f double prime. So I'm going to say f double prime is less than 0, and I'm even just going to state when f is concave down. So I'm giving the justification first. This occurs on the intervals. And then I'm looking for all the places where f of x is concave down. And I'm just saying this for right now. You would never have to do this on a test or quiz where you're just like guessing these values, but I'm going to say negative infinity to negative 3.1. And I'm going to go over here. Concave down looks like around negative 0.9. Oops, I don't know what's up there. To infinity. And then I'm going to do the same thing. You pick out f double prime is greater than 0. When f is concave up. And this occurs on the intervals, or on the interval in this case. What interval is this? It looks like negative 3.1 to negative 0.9. And then you can also say f double prime, we can say is equal to 0, because again, f of x is smooth, like it's nice, everything like nice is happening in this, so this just looks like some sort of like quartic function maybe. So f double prime is equal to 0 when f has point of inflection. That means when f changes concavity, which occurs at x equals negative 3.1 and negative 0.9. So we knew all sorts of things. This was a graph of f of x, and I can tell you all sorts of stuff about f prime and f double prime. Let's go to a different graph. So how about this time I have a graph of f prime. And now I need to tell you all about f of x. So this is where you really don't want to mess up and think you're talking about f when you're really talking about f prime or f double prime. So this is the graph of f prime. Make sure that you know that. If you need to rate it really big over here that this is f prime, do that. Remember that f prime is the slope of f. So think about it. Try to write down everything that you can about f, knowing this is the graph of f prime. Ready, set, go. Okay, I'm going to keep going because this is a video and I can do that. So f prime, I'm going to say f is increasing, so I'm not even looking at the graph yet, when f prime is positive. And now I'll look at the graph, which occurs, remember positive would just be above the x-axis or below. So on the intervals, so positive is above the x-axis, negative is below. On the intervals, and I'm going to say negative 2 to 1. So here all the way to there. Oh, I just messed up the graph. And then from 3 to infinity. Likewise, f is decreasing. When f prime is less than 0. Which occurs on the intervals. I'm looking anywhere below the x-axis, so negative infinity to negative 2, again an x value to an x value, and 1 to 3. I can say when f has relative extrema, so f has a relative max. Think about it, f of x has a relative max when I'm going from increasing to decreasing on the graph of x, which means when f prime changes from positive to negative, you can't just say changes signs. And this occurs at x equals, and you can only say the x value because I actually don't know what the original function is to say the coordinates, but from positive to negative, I can see if I'm reading from left to right, this would be negative to positive, so that's a relative min. I'll come back to that. Positive to negative is going to be right here at x equals 1, negative to positive at 3. So at x equals 1, and I can also say f has a relative min when f prime changes, I don't know why I'm writing so big, from negative to positive. Which occurs at x equals, this would be at -2 and at +3. Okay. Oops. Okay, so that's all sorts of things about f of x when we're given the graph of f prime. We know so much, and actually we know a little bit more in a second. Okay, which I'm going to come back to this, and I'll maybe even put an asterisk at the bottom on this side. If I say conclusions about f double prime, so f double prime is the derivative of f prime. So all those things that we said in that last one, when we were talking about the connections between f prime and f double prime, before we were talking about f and f prime, we can make those same kind of connections where we're looking at the slope. So I know right now, as f prime is increasing on the intervals, and I'm going to say increasing from -∞ to -1 and 2 to infinity. So I'm looking at all the places where f prime is increasing. That means then f double prime is greater than 0. And so I'm going to actually kind of go off that for a second, and I'm going to put a little asterisk here. What does that mean if f double prime is greater than 0? Well, you know what? I'll put it in parentheses so we can see it here. That means f is concave up on that interval. So we actually know more information because we know f double prime is greater than 0. So when we have the graph of f prime, we can learn all sorts of things, which is pretty great. Okay, so how about as f prime is decreasing on the interval? So I can see where f prime is decreasing, it'll only be from -1 to +2. Again, an x value to an x value. F double prime is negative. So we know that piece of information about f double prime. And then that also means, like, so here I'm doing some extra asterisks over here because we know that means f is concave down. On that interval. Okay, so if I'm going from concave up to concave down or vice versa, I can say f has relative extrema, or f prime, I'm sorry, has relative extrema, meaning mins or maxes, at x equals -1 and x equals 2, and these are nice smooth curves. Therefore, f double prime equals 0, and I'm going to say as f prime has no sharp turns. That's an even better way to say this. So we know does not exist. So if we have f prime has relative extrema at x equals -1 and x equals 2, f prime equals 0, and changes signs, I can see that f double prime, because all the stuff we set up here, so f double prime changes signs. And what does that tell you about the graph of f? Therefore, f has points of inflection at x equals -1 and x equals 2. So much information, and it's awesome. Were you singing that too? But that wasn't really my singing voice, except that was like a low singing voice. But just from a graph of f prime, we know so much. Yeah, this crowd goes wild. I'm guessing there is no crowd. But let's do one more page. You guessed it. This is a graph of f double prime. What can I say about f? So the graph of f is all about, when I have f double prime, is all about concavity. So you should be thinking concavity if I have the graph of f double prime. Okay, so f is concave down when f double prime is what? Is negative. This occurs, and now I'm going to look, when is f double prime? On the intervals or interval. In this case, there's only one place where f double prime is less than 0. So really important to remember, less than 0 be below the x-axis, more than 0 above the x-axis, which is different than increasing or decreasing. So this occurs on the interval, I'm going to say negative infinity to 0. Remember, an x value to an x value. F is concave up when f double prime is greater than 0. This occurs on the intervals, and I am going to say intervals even though there are some textbooks and some people that would argue otherwise, and if you only have one answer choice in the AP exam and it includes this number, that's okay, because they're never going to give you something that would be different, because textbooks and people argue about this. But concave up was going to be where f double prime is greater than 0. I'm going to say 0 to 3 and 3 to infinity. So much stuff. Okay. The other thing that I'm going to say is f has a point of inflection when f double prime changes signs. This occurs when, and the only place I can see from positive to negative or negative to positive, I don't have to worry about here because it's not changing signs, that would be at x equals 0. Okay, one more. We can do it. Conclusions about f prime. So f prime is the original function, and this would be the slope. So f double prime is the slope of the tangent, or the slope of f prime. So let's think about this. It's like I'm giving the derivative, but I'm finding things about the original function. So I'm thinking all about increasing or decreasing. So f prime is increasing when f double prime is greater than 0. This occurs on the intervals. Notice I'm not going in the same order every time. Yours could be in totally different than mine. If you tried this and you're like, I did decreasing first, that's okay. This occurs on the intervals. This says when f prime is greater, or f double prime is greater than 0. So I'm going up here, 0 to 3, and 3 to infinity. Keep going. F prime is decreasing when f double prime is greater than 0, or less than 0, I'm so sorry, which occurs on the interval. I'm looking under the x-axis, so I'm thinking from negative infinity to 0. F prime has a relative max. Look at that. Or let's start with relative min. Where would f prime have relative min? When f double prime changes from negative to positive. Negative to positive, negative to positive. Think about decreasing to increasing. Oops, sorry, I wrote it down here. Decreasing to increasing, negative to positive, which occurs at x equals 0. Does it have a relative max? F prime has a relative max when changing from positive to negative. That doesn't happen. So I'm going to say f prime does not have a relative max, as f double prime does not change from positive to negative. I'm always reading from left to right. That's where I'm getting, hold on, I'll look. Positive to negative. Left to right, negative to positive. This would be positive to still positive. Reading left to right. Whew. If you need to stretch out your hands, now would be a good time. But we did it. Hooray! That would be how I cheer if I was a leprechaun, but I'm a human and I just cheered like that, so I guess that's how I'd cheer when I was a human. Yay! Okay, thanks for being awesome. Thanks for being you and for working and for learning, and I appreciate you. Please let me know what you need. Thanks. Bye.